All right, Algebra 1A students. Welcome to your video on part 2 of lesson 5-7. Today we're going to continue talking about some statistical stuff, just a little bit of vocabulary really that deals with two different variables in a statistics kind of situation in the real world, okay? So we've been making scatter plots over the last couple of days. And we've been making scatter plots that involve two quantities a lot of times in real life. Like we had a problem where we had what year it was versus how many people were going to amusement parks and things like that. So kind of real world situations, and we're going to look at more of those in this video. Specifically, we're going to look at this idea of causation. This is when a change in one of your variables specifically and intentionally causes the change in the other variable or in a second quantity, okay? The key for you guys to remember is that sometimes there is a correlation between two quantities, meaning we have a correlation either positive or negative on our scatter plot, but that does not always mean that the relationship is causational, okay? Does not always imply causation. Just because there's a positive or negative correlation does not mean there's always causation, okay? So most of what your homework is for your practice problems tomorrow are looking at what situations would be causational relationships and which ones are probably just correlation relationships, okay? So let's look at this first situation here in letter A. Problem 4, it says the number of loaves of bread baked and the amount of flour you use. So there's our two numbers. So if I make a little sketch for myself of like, okay, this is like the loaves of bread I'm going to make, L-O-A-V-E-S, the loaves I'm going to make, and then this axis here is the amount of flour that I use. And certainly there is going to be a correlation here, right? Because the more bread I make, the more flour I'm going to have to use, okay? So there's definitely a correlation here. It's probably a positive correlation, right? Because as the number of loaves increases, the amount of flour I need to use also increases. More loaves means more flour. Now the question is that a causational relationship? Does making more loaves of bread cause me to use more flour? And the answer here is yes. Yes, there is causation because physically making more bread is what causes more flour to get used. Okay? The answer there is absolutely yes. The more loaves I make, the more flour I use. It's the causational relationship there. Okay? So that is yes. When we're making things, yes, causation. It is causing something to happen. Okay? That's yes. Now this second example is a little bit different. This one says the number of mailboxes in a city and the number of firefighters. Okay, the number of mailboxes and the number of firefighters. So again, this is something where I am going to have a correlation probably. Okay? Because if I have more mailboxes probably means more people and more neighborhoods and more houses. And if I have more houses, I probably need more firefighters, right? So again, I am going to have this correlation relationship where more mailboxes means more firefighters. That's definitely true all the time. However, the question we have to ask ourselves is, does more mailboxes cause more people to become firefighters? Does creating more mailboxes or putting more mailboxes up in my city cause more firefighters to appear? And the answer, of course, is no. It seems like kind of a silly question, right? Mailboxes don't cause anything to do with firefighters, right? Physically putting up another mailbox is not going to create a new firefighter. However, there is this correlation between the two because more mailboxes probably means more firefighters, but it's not a causation relationship, okay? So hopefully the difference there is starting to make a little bit of sense. Now, I have a couple here I'd like you to look at, okay? Look at these two questions here, A and B, and decide if there is a correlation, probably is, and if there is, then is that a causational relationship or probably not causational? So the simple fact is it yes, no on the correlation and yes, no on the causation. Okay, take a look at those two scenarios, figure out if there's causation or correlation, and then come on back and I'll show you what we should have. All right, in the first one, letter A, the cost of a family's vacation and the size of their house. Is there a correlation? Yes, there is. Right? People with bigger houses can probably afford more expensive vacations, or people that can afford more expensive vacations can probably also afford bigger houses. Right? Bigger house probably does correlate with size of house, or excuse me, size of house does correlate with the cost of a vacation. However, the question we have to ask is, does taking a more expensive vacation cause our house to grow bigger? And of course the answer there is no. No way. No. Spending more on a vacation does not cause the size of your house to grow bigger. Okay, that's just not true. There is a correlation, but not causation. Now in letter B, there is, of course, a correlation between how much time you spend exercising and how many calories you burn. And in addition to that, there is also a causational relationship here because exercising for more minutes actually causes more calories to be burned. That's just the way exercise works, right? So letter B does have causation. Letter A does not, all right? If you have questions about the difference between correlation and causation, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.